Let's answer this question before us. So as you can see, it's taken from a Year 12 exam, so Vcaa 2021, multiple choice question 15. 4 fair coins are tossed at the same time. The outcome of each coin is independent of the outcome of any other coin. The probability that there is an equal number of heads and tails, given that there is at least one head. So we need to find the probability that we get an equal amount of heads and tails, given that there is at least one head. Okay, how are we going to approach this? If we have an equal amount of heads and tails, and we're flipping this thing 4 times, what I want you to realize is that means we have to have 2 heads and 2 tails. That's the only way to get an even amount. So instead of writing it like this, what I'm going to write it as is that this is the probability of getting 2 heads. I could have said it's the probability of getting 2 tails as well, but the reason why I'm saying heads is because, as you see here, it says given that there is a probability of getting at least one head. So here I can say, well, this is the probability of h being greater than or equal to 1. So I can write them both in terms of the heads, and that's important. Okay, let's now talk about the probability of getting 2 heads. Now, what is that going to be? Well, we've got 4 fair coins. So we need to think of all the different ways of getting 2 heads if we're flipping a coin 4 times. Okay, so the obvious one would be like you get a head and then a head and then a tail. Or maybe you get a tail and a tail, then a head, then a head. Or maybe you get a head and a tail and a head and a tail. Or maybe you get a tail and a head and a tail and a head. What's another way that you could do this? What if you got a head, a tail, and a head? Or a tail, a head, well, that's an ugly H. A head, and a tail. So that means there is 1, 2, 3, 4, 5, 6 different ways of getting this. Now, how many options in total? So what's the total sample space? Total sample space. Well, to figure out the total sample space, all you need to do, if we're flipping a coin 4 times, you can just go, well, it's going to be 4 times, we're flipping a coin 4 times, and there are 2 options each time. So it's just going to be 2 times 2 times 2 times 2. If you think about it for a second, don't write this down, but if you kind of think about it, it's going to be heads, then tails, then heads, then tails, then heads, then tails, then heads, then tails, and so on. Well, as you can see here, if we went 2 times 2, this shows us that we've got 4 options, 1, 2, 3, 4. And if we were to take all these 4 options and times it again by 2, that means we would have 2 times 4, we would have 8 options. And sure enough, if we were to break all of these up, we would have 1, 2, 3, 4, 5, 6, 7, 8. And therefore, the logic applies that if we go times 2 again, that means we're going to have a total of 16 outcomes. So that's kind of the thinking behind getting the sample space there. So that's going to be 16. So that means the probability of getting 2 heads is going to be 6 on 16. Then we have to figure out the probability of getting at least 1 head. The probability of getting at least 1 head. So we come over here. What's the probability of getting this? Now, do you see how I said that this is the probability of getting at least 1 head? The reason why I phrased it like that is because as soon as you're in this situation, you know what you're going to do is say, well, that's the probability of, like, take the entire sample space, or a probability of 1, and then subtract away the probability of you not getting any heads at all. So the probability of the amount of heads you get is 0. Let's say that. Well, what's that probability? What's the probability of you flipping a coin 4 times and getting no heads coming up? Well, if you kind of think of your tree diagram for a second, so don't write this down. Sometimes it's just helpful to visualize this in your head. Picture your tree diagram. So you got tails, then heads, then tails, then heads, then tails, then heads, then tails. So I've kind of just shown you one side. Of course, this kind of keeps on going here. But do you see the probability of you getting 0 heads is going tail, 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 tail. So that means we would go a half times a half times a half times a half. And that's the same thing as saying a half raised to the power of 4. So that means we're going to get 1 minus 1 on 2 to raise to the 4 is 1 on 16. Okay, then once we've done that, we're simply going to subtract these from each other, and that's going to be 15 on 16. Okay, then the next thing that we do, as you can see, I'm really taking my time with this question. You could have done it a lot quicker if, of course, you didn't have to explain every step. So this is probably not how long It should take you, but we're learning. Now, I want to find the probability of heads equaling 0 given the probability, sorry, I'm not going to write probability again, of the heads being greater than or equal to 1. Well, that's going to be 6 on 16 divided by 15 on 16. So I'm just taking one and dividing it by another. You might actually stop here for a second. Actually, before I go into this, because you might be thinking to yourself, well, isn't strictly the definition of conditional probability, like it should be this equals that intersection of this over the probability of this being greater than or equal to 1. Now, what's the probability of getting two heads intersection of getting at least one head? Do you see how that is the same thing as the probability of getting two heads? Because by definition, if you're going to get two heads, you've at least gotten one head. These are what we would call, one is the subset of the other. So that means we can just kind of think about it as that, and just kind of saying that out loud. The intersection of two heads, given at least you have one head, well, it's just going to be the probability of two heads, because to get two heads, you've gotten one head. All right, we keep on going. This. Okay, then what did we say? The probability, let me zoom out here. The probability of getting two heads is 6 on 16. 6 on 16. Divide that by the probability of getting greater than, equal to or greater than one head. That was this one. Then you can do stay, change, flip. If you do that, that cancels with this, which means you get 6 on 15. Let us hope that is one of the answers. Actually, we should simplify this. We should simplify, because both of those can be divided by 3, in which case 6 divided by 3 is 2, and 15 divided by 3 is 5. So my answer should be 2 on 5. We come over here now, and would you look at that? That's our answer, 2 on 5. So hopefully that makes sense. I went through this really quite methodically, I feel, but make sure to reach out if you've got any questions about this.